Hello gamers, welcome to Xcoder videos once again and to a new session of the Microhard series. This is session number 13. We're getting closer to the end of our Microhard series. We just have a few more tasks to perform, I'm sure, before we've done all of the available tasks. And in this video, we're going to be looking at the RAM 4W16B element. And this is going to be compared to the last one we did, the counter 4B that we did in session 12. This is going to be a lot simpler than that one. And so I think we can do it here in just a few minutes. So let's take a look at the specification. This is a 4-register 16-bit RAM specification. That is, it is 4 registers of 16 bits. And each register will contain 16 bits of information, and it is addressable so that you can load or receive any one of these 4 bits that you want simply by addressing them and reading the chip or writing to the chip. It has a 16-bit in bus in order to store values. It has a 16-bit out bus in order to retrieve values. There is a 1-bit load pin that is placed high when you want to save a value, and then the address is 2 bits, and using 2 bits you can address all of the 4 registers that are in the chip. You can see some example inputs and outputs down below. That's just really a very few examples of what can go in the chip. And if we go over there and just take a look at it real quickly, it's not going to show us very many. That's about all the examples are going to go. But with 16 bits, 16 bits can contain about 65,000 different combinations of bits. And then you multiply that by 4 because of the address, because of the 2-bit addresses, and multiply it once more by multiply it once more by 2, and that gives us something like, well over 100,000, 100 to almost 200,000 different combinations that can of inputs that we can have. And with every input, there are actually almost, it's not infinite, but it's a very large number of possible outputs for every one of those thousands of inputs that could be. So the possible combinations is staggering, and I don't even want to try to come up with an exact number. So let's go on and take a look at the diagram in digital that I have worked out. Again, you can see this is a lot simpler than the counter component that we created the last time. This has only 4 registers. The register is one of the components that we created earlier. These are 16-bit registers, and it's got a one demux or demultiplexer, and it's also got a multiplexer in there. And we've got a clock represented in our design because these registers require a clock in order to, it's part of the process of setting the values in the registers. We've got a 16-bit input, a 2-bit address, and a 1-bit load. Let's look at how the registers are addressed. You see that the address, the 2-bit address, supplies the 2-bit address of this demultiplexer. It also supplies the 2-bit address of this multiplexer. And basically the 2-bit address specify which one of these outputs on the demultiplexer the value that's contained within the load bit goes to, and these 4 wires go to the enable pin of these registers. I think the enable pins are called the load pins in Microhard. On the address, the output for each of the registers go to this multiplexer, and the 2-bit address specify which one of these 4 pins, or which one of these 4 wires is enabled to go to the output of the component. And that's all there is to this design. So I'm going to pull this over on the other monitor, and let's go ahead and start specifying our design. As I said, we need a demultiplexer. We'll just call it demux for short. And this is a four-way demultiplexer. Nope, hit the wrong key. I want to get the control input. And we've got a mux multiplexer. And this is a four-way 16-bit that we need. This this demux is a four-way 1-bit demultiplexer, and the multiplexer is a four-way 16-bit bus demultiplexer. So that's exactly what we need for our design. And let's see. Let's go ahead and bring this down. We've got plenty of room here for this one. And we need 4 registers. Reg 1. And these are going to be the 16-bit variety. 16-bit bus. 4 of those. And I believe that's all the components that we need. Now to wire them up, let's wire up the load first. That goes to the demux in, and Now let's wire up the address line. And it wants to go to the DMUX select. And to the MUX select. Then we have the N values. That's the 16-bit ends, and that will go to each of the registers. Reg 1N, Reg 2N, Reg 3N, and the Reg 4N. And then the DMUX output goes to each of the registers. That goes to the Reg 1 load. And let's just copy these to save a little bit of work. DMUX out 2, DMUX out 3, and out 4 go to the Reg 2, Reg 3, and Reg 4 load. And then the output from the registers go to the multiplexer. MUX N1, need 4 of those. Two, 3, and 4. 2, 3, and 4. And then the multiplexer output goes to our out pin. And that's all there is to the RAM4W16B. We should be able to test this now, see if we've typed everything in right. If so, we should get a verification passed. And it gave us that. It ran, it ran a bunch of tests here just to make sure that everything is hunky-dory. And everything passed. Everything worked just right. Beautiful. And that's all there is to the 4 register, the 4 register memory here that we've created. So let's press enter and see what we get today from new instructions. We've got a new design unlocked, which is the RAM 64K W16-bit. So that is quite a step up from the 4 byte of 4 words of memory that we created. We've got 64K of memory now for 16-bit. And we've got, looks like 2 new tasks are available to us. So let's see what it has to say. We've unlocked the CPU and we've unlocked the decoder. And as you recall last time, the great things await. And we've got everything ready to finish our computer. We need to create a decoder, understand it well, and we need to create the CPU. Before we complete our video today, I want to pass on a little bit of information. Because we are coming up to the end of the Microhard series of videos, I know that some people are a little disappointed when they come to the end of this game because it's such a sudden stop. They've enjoyed making the components that are found within the game and so on, and uh, they get to this point and everything ends, and so they're kind of disappointed in that. I thought what might be fun for some of our viewers would be to have uh, a a challenge to create an additional group of components, so different components with varying degrees of complexity. And of course, we couldn't do it in microcoder, but we can do it in digital. And so I thought on Friday nights at 7 o'clock Central Time, I would have a live video where we would present various challenges to our viewers, give the specifications for the components that we want to build during the next week, and then look at the resolution to those uh, uh, components in the next live session a week later, if that's possible. And so coming up one of these weeks very soon, probably not this week, but maybe next week, on Friday night at 7 o'clock. If you are interested, you can come in and participate live in that live video. That's all we have for today. I appreciate your watching again. Come back next time and we'll probably start working on the decoder and then the CPU.